I'll have your tests on Thursday. I'm about 2/3 of the way through them. I just haven't finished grading them all yet. Taking me a little longer than I thought they were going to take me, but not on you guys. It's just there's lots of little things I have to look at while I'm going through grading them to give you guys partial credit and stuff. So, all right. So while you're listening to me talk, copy what's on the board. Out of everything in pre-calc, this is considered to be the most difficult because, first of all, it's proofs, but it's not necessarily the proofs that you would have done like in geometry class where you were trying to remember all the postulates and stuff like that. It's more of rewriting trig equations and trig functions. So what makes it so difficult is there's a ton of different ways that you can go with these. And sometimes you just don't quite know like the steps to do to get to the final answer because everyone is going to be different. All right. So I'm going to show you some strategies and things like that that'll help you figure these out a little better. But in the end, these just literally come down to practice. Okay. Out of everything, though, this stuff is very, very useful going forward in calculus and those type of classes. Because what you'll run into a lot of times when you're doing differentiation or more so in integration is that you might be able to do a problem one way with the trig equation. However, if it's formatted in a different way, the integration of the differentiation is going to be almost impossible for you to do. So being able to rewrite a function in another way that makes life easier is going to be very helpful to you, right? Which is really what this is supposed to be focused on. There's actually a bunch of different rules that you're going to look at. We're going to look at these three starting today. We'll get to some other ones down the line. Alex does this a few different ways. So I'm going to actually show you some of the stuff. We're going to do it out by hand, and then we'll go to Alex and put the stuff in Alex so you can see how to put those things in Alex. All right. So the first few that we're going to look at is literally, I'll show you. Just looks like this where you're just going to put the answer in. So it won't be too bad. All right. So they want us to rewrite this one. And they want it written at the end with a single trigonometric function. So right now we have two. They want it to be written as one trigonometric function. So if you go back and you look at what you have here, we have what the sines and cosine or the secants and cosecants and stuff turn into. So first step I would do is let's look at those and change them to sines and cosines. A lot of times, if you look at these rules here, a lot of the rules focus around sines and cosines. So if you can get them to sines and cosines, we might be able to do a lot more work with them. So let's start with that step. So cosecant is what? That is sine. It's 1 over sine. So I have 1 over sine of x. And then the secant is 1 over cosine of x. What's the rules for dividing fractions? You change flip. So I have 1 over sine of x times cosine x over 1. So this ends up being cosine of x over sine of x. Now, we have one of those. One of those was on the previous screen. That's cotangent. So cosine of x over sine of x is cotangent of x. And that is a single term or a single trig function rewrite. So cosecant of x over secant of x goes to cotangent of x.
Couldn't you just automatically assume it's a problem and it's going to be one of the portion that
It could be. But not always. Because especially when you're dealing with the inverse functions like this, you can get things where if it was, say, cosecant of x over cosine of x, like it might look like that, but when you're trying to flip things around, it doesn't end up working out the same way. So, all right, so we have sine of x times cotangent of x. So what do you want to try with this one? Same thing, we want to get it to a single trig function. Huh? Change. Yeah, let's change cotangent to sines and cosines, right?
Yeah.
So I have sine of x there, and cotangent is cosine of x over sine of x. And now we have a sine of x on the top and a sine of x on the bottom. So this equals this cosine of x. What about this one? Mm-hmm. The 3x does nothing. Okay. Remember, if you look back at the functions, they had that u there. That u can be anything. As long as they're the same, we can do this. So if one was sine of 3x and the other one was secant of 5x, I couldn't do it. I would have to use some other information. But since they're the same, they can be treated as they're the same. So this ends up being sine of 3x times 1 over cosine of 3x. What's sine over cosine? It's tangent. So it's tangent of 3x.
Would it be wrong to put sine over cosine?
Yes, because it wants it as a single term. And that's actually, it's one of the nice things. So one of the nice things about how the way Alex does it is they're going to give you the beginning and the end, so you know where you're at, and most of the proof ones, so that you know where you're going to. When you leave here and you do other stuff, you won't have the ending. So in some situations, tangent of 3x might be the easier way to go. In some situations, sine over cosine might be the way to go. Or you might want sine of x and cotangent of x because you want it as a multiplication. So it's like that's the thing that you're going to have to understand down the road is what format do I want it in to get it. What we're looking at here is how to translate it into a bunch of different things, knowing that they are all equal to each other. So it's more of the process of being able to figure out, okay, this is equal to this, and I can make this change, which is equal to this. So sine of x, cotangent of x is literally, or sine secant, sorry, is the same as tangent. Like those are exactly the same things. If I graphed those two things, I would get the exact same graphs. Okay. All right. Let's look at the next set of them. All right. So let's look at this one. Again, they want this one down to a single trigonometric function. All right. So no addition, subtraction, not multiple ones. What do these look like? Yeah. These look like these Pythagorean identities here. So let me copy this one down. We've got our Pythagorean identities. So we have this is right there. So 1 plus cotangent squared of x is cosecant squared of x. So I now have CSC squared of x and then cosine squared of x. All right. I still have two functions though, right? So what's the next thing I want to try? Yeah, let's change that to 1 over sine. So this is going to become 1 over sine. So I have cosine squared of x over sine squared of x. So from this step to here, we use the Pythagorean. From here to here, we use quotient. Actually, sorry, we didn't use quotient. We used reciprocal for that one. And then from here to here, we're going to use quotient. What's cosine over sine? It's cotangent. So it's cotangent squared of x. Sine over cosine tangent.
Is it always going to be +1?
For your Pythagoreans?
Yeah.
No. So we could, if you had the sine squared of x plus cosine squared of x equals 1. That's the Pythagorean identity, right? Cosine squared of x equals 1 minus sine squared of x. So the Pythagorean identity can be shifted around to give you other things. So it's not always going to be a plus. You could have minuses in there. Yes. Yeah. Or something you could pull out. So like, right. If it was 2's, you would have to be able to pull out a 2, like to be able to, and you'd still have the 1 minus the sine squared of x in that situation. So, yeah. All right, let's do another one of these. All right, try this one. Hold on, I'll pull my Pythagorean identities over so you can have them on the screen. Think back to what I just said a second ago when you asked if it always has to be a 1. Look about factoring something out of this one. Because the Pythagorean identities all have 1s in them. If I don't have a 1 and I want to use Pythagorean identity, somewhere I've got to get a 1. So, no. What's the same in both terms? Cotangent of x is the same in both terms. So I'm going to pull out a cotangent of x. And I'm left with secant squared x minus 1. What do you mean?
Like add like the minus cotangent x, add that to the other side, and then move.
Oh no, see, I don't have an equal sign. So that's one of the things, and actually that's a good thing because the next few problems I'm going to have will have an equal sign. You do not want to work at both sides. You want to work on one side. That's why these problems don't have an equal sign. We're just rewriting the expression. So now, so that step right there, that's known as algebraic. We just did an algebra step. We just factored something out. Now I have secant squared x minus 1, right? That kind of looks like that one right there. If I move the 1 over. So CSC or secant squared x minus 1 is going to be what? It's going to be tangent of x. So I have cotangent of x times tangent of x, or tangent squared of x.
That's it.
I want one term. We have two still. Yes. So now this is one of those situations where we say, okay, we'll switch things to sines and cosines. This one we might not want to switch to sines and cosines. We do know that cotangent is, is the reciprocal of tangent. So if we change this to 1 over tangent of x, and then tangent squared x, that's reciprocal. So tangent squared of x over tangent of x becomes just tangent of x, and that's algebra. Notice what I'm doing on the sides. How many of you remember doing proofs in high school in geometry class? Okay. Or how many of you remember had your teachers when you were doing the steps for solving equations, you had to write what you did next to them? Same concept. You're telling me what you're doing to go with it. When you start to look at the proof steps, it's going to ask you what rules you're using. I'm using an algebra rule. I'm using a Pythagorean identity. I'm using a reciprocal rule. Those are the rules that I'm using to go from step to step. Okay.
What were people solving where they found these rules?
Astronomy class. In all honesty, when they were looking at a lot of this stuff, they were looking at waveforms. Because trig does a waveform. So they were looking at planetary motion and stuff like that. And that really goes into trigonometry. We've now found a lot more uses for it at that point. The Egyptians dealt with Pythagorean theorem thousands of years before Pythagoras was around. So they were trying to figure out right triangles. They looked at the Greeks then started looking at was a common ratios between them, those which eventually became your trig functions. But the more complicated ones and being able to convert them and stuff like that, that really goes into your physics and your science classes and why we'd want to be able to do those types of things. So, okay. All right. Let's get into some of the actual, I think actually, maybe we might have one more of these. Nope, we'll get actually into the tricks. There is no numbers in these. There's no numbers. Well, there'd be numbers, but there's not. We're not solving for an answer in these topics. All right. This is how the question's going to look out for the first few of them. So the first few topics that they have you go into actually has you. It gives you all the steps. You're just telling them what they did. Okay. So it's kind of leading you into the more complicated proofs because in essence, what you're going to do, and I can tell you right now what's going to be on your test, this will not be on your test. You're going to have this and that, and you're going to tell me how to get from there to there. Okay? That's what's going to be on your test. You're going to tell me what break down your steps and then tell me which rules you use to get to those steps. the nice thing is that will lead you up to those points. You'll get better. All right, so looking at this one, this is why I said you don't want to work on both sides. We only want to work on one side of the equation, and we're working out. So in essence, we're trying to go from here to there. It's not really an equation in that response. All right, so how did it go from here to here? Yes, it is algebra, so the rule is algebra, correct. But what did they actually do? They FOILed. Okay, so they FOILed that out. So yes, the rule is algebra, but they really FOILed. So remember, we had sine of x plus cosine of x times sine of x cosine of x. And I'm running out of room. So you FOIL it out, you get the sine squared x plus sine x cosine x plus sine x cosine x plus cosine squared x. And that's how they got that. How did they go from here to here? Or what did they do? So this part right here is still there, right? So really what's missing is sine squared x and cosine squared x. What's sine squared x plus cosine squared x? That's 1. That's where that 1 came from. That was a Pythagorean rule.
Why is it 1?
Because sine squared x plus cosine squared x equals 1. That's one of your Pythagorean identities.
Oh,
Okay. And that's how they go from that step to that one. So in Alex, when you look at this one, it has rule. You click on the rule, it gives you a drop-down menu. Here's a nice thing about this. See these question marks here? If you click on the question mark, it shows you all the rules. Okay? So quotient shows you the quotient rules. Pythagorean shows you Pythagorean rules. So, yes. I'll give you the rules. So, because the rules are something you're either going to look up or memorize at some point. I would highly suggest trying to memorize them, at least some of the beginning ones, like the Pythagorean rules, the quotient rules, reciprocal ones. I would definitely remember those. The odd and even ones, the double angle ones, those, I even looked them up. I haven't really memorized them. But the Pythagorean quotient rules, those things do come up a lot. So memorizing those would be very helpful.
so this entire chapter proves.
Yes. Chapter 8 there's the law of sines, the law of cosines, but chapter 7 is all proofs.
What are proofs?
Proofs is basically just how you're proving that this statement is true. Okay, so is this really this? And you got to tell me, break down the steps. How do you go from that using stuff that we've known to be true? Sure. So the thing about math proofs, so in science class, you do a bunch of experiments. You're like, okay, I believe this to be true. However, I could do an experiment the next day that shows you're false. Okay, because that's the nature of science and experiments. In math, this statement here will always be true. Okay, and because we've used things that we've proven to be true before that point, there's no other way that they can come up and say this is false. Okay, so that's one nice thing about math. When we say something is true, it's always true. It will never change. So we did from there to there, we did algebra. From there to there, we did Pythagorean. So that's what they're looking for in these problems, is you telling me what they did to go from each step to step. The one thing that when you're doing these topics, they're really quick topics. Okay. You're going to be able to look at these and go, oh, okay. Yep. That's Pythagorean. That's what you're going to do that really quickly. I want you to stop and really look at the question. What I want you to do when you're going through these topics is look at the steps they're doing. Okay? Look at, like, when they're looking there, it's like, okay, when I see this, I want to change it to that. Look, you want to look for those type of things. Because what's going to happen, this is the change between these topics and the next set of topics. That wasn't what I wanted to do. Oh, I had to do it. Okay. This is the next set of topics. Notice they give you this and there's nothing. You now have to do the step and tell me what you did. Okay? So when you're going through and doing these problems here, start to understand what they're looking for and what kind of steps you can do. That's why I said really take a look at the steps more than just get the answer and go on through the topic. Because when you get to the other ones, you're going to go, huh? And be totally lost unless you really understood what they were doing over here. All right, so let's go back and look at what they're doing over here. What did they do to go from here to here? Yeah, they did a Pythagorean. The goal was to get this to be a single term, right? So somehow I've got to change the secants and stuff like that into something else. Like, so we're looking at getting rid of things. So going from here to here, got rid of my addition and subtraction. Okay, I got rid of my subtraction, so I no longer have that. A lot of times, for what you guys will know, whenever you see anything with addition and subtraction, the only way to really get rid of it is Pythagorean identities. The only way to really add it is Pythagorean identities. So when you're thinking there, think the Pythagorean. So like we have the secant squared x minus 1, that goes to the tangent squared x. All right, so that would be Pythagorean. Now again, we got to get this down to 1. A lot of times, breaking things down to sines and cosines make your life a lot easier. Notice though, because this is something that when you start typing them in and having to write down the things are really easy things to lose. You'll have the tangent squared x there, that'll be fine. Tangent goes to sine and cosine. They're both still squared. Don't lose the square. Okay? So remember, like if that was a 3x, they'd all have to be 3x's. Since this is a square, those have to be squares as well. Okay, so what rule did they use to go from here to here? Huh?
1 over secant.
Nope. This is the quotient rules. Reciprocals are the flips over. So reciprocals will change tangent to cotangent. So if we did the reciprocal, that would change it to cotangent, which I didn't want. This to there, that's the quotient rules. I know they're very similar, like because they both have division in them. Really easy to get it mixed up when you're putting them in here. So we've switched to sines and cosines because now everything's in sines and cosines. Makes life easy to cancel stuff out. So now they've just taken those two cosines and canceled them out. That's an algebraic step. Okay. So we go back over here. We did Pythagorean, quotient, and algebra. Yep. Same. I just copy and pasted it. All right, so let's look at this one. Yeah, this topic has problem type 1, problem type 2, problem type 3. The proof ones goes up through problem type 7, I think. So they just get progressively harder. All right, so let's look at this one. So they want to change 1 plus tangent squared x cotangent x to secant x cosecant x. So notice that between the first and the last one, there's no more addition and subtraction. So odds are I'm going to have to do some kind of Pythagorean identity there, and that's what they actually end up doing first. So they want to get rid of that part first. So they take the 1 plus tangent squared x and change it to secant squared x. So remember your Pythagorean identities, they gave you those 3, but it's also the manipulation of those 3. So you also can move things around to get an equal something else. All right, so we got secant squared x cotangent x. What they do in the next step? Yeah, they use the reciprocal identity. When you're going through and doing this out by yourself and actually having to write out all the steps, you're going to want to combine steps. You can do that as long as you're using the same rules. Okay, so a lot of times you might want to go right from the secant squared x and cotangent x to the 1 over cosine squared x, cosine x, sine x, because you're changing everything to sines and cosines. However, in that situation, you're using 2 different rules. You're using a quotient rule and a reciprocal rule. Okay? So when you're typing them into Alex to put them in, you have to put those on 2 separate lines. Yes.
So to get the cosine of x over the sine of x, you would just put it to the cotangent 1 over tangent, and then you would
No.
tangent to sine.
No, you can do that as a quotient rule. These 2 or this one to that, you could have. That's just the quotient rule. Okay. From here to here, that's a reciprocal.
Yeah.
So they just did the reciprocal rule first, and then they did the quote to change this one, and then they did the quotient rule to change that one.
Okay.
So you don't have to change this one to 1 over tangent because you did the reciprocal rule. We just did the reciprocal rule on this one. We don't have to necessarily do them both.
What would that give you?
It would do the same thing. You could still, this would still have been the reciprocal rule, and then you change the 1 over tangent to, yeah, it would have just added some extra steps. All right. So we've got our reciprocal rule, we got our quotient rule. The goal was, in this case, you're doing it, getting everything in sines and cosines. A lot of times, if you can't think about where to go, try to go to sines and cosines. It allows you to cancel a lot of stuff out sometimes and simplify things down. Now, in this situation, we've got cosine x and cosine squared x. We can cancel those out. That's an algebra step. If you're going to do multiple algebra steps in a row, you can combine all those together and take algebra and just write it as one step. Okay, which we will do later on in some of the other problems, because there's been a lot of times where we're manipulating things. If it's multiple steps of the exact same thing, you can combine. So we're now at this step. What did they do to go from that step to that step? That's the reciprocal rule. In that case, that's all you wanted in this one. You typically do not want to leave things as 1 over something. At that point, you typically do want to change them. So you're rarely going to see something left in that step there. It's going to be always changed to this step. No, this one's they just did the reciprocal rule. So 1 over, because you can't cross multiply because the equal sign's not between them. You'd multiply a cross, but not cross multiply. So we've got Pythagorean, reciprocal, quotient, algebra, and reciprocal. All right. Now the fun starts. Okay, so basically your goal is to go from here to there. Oh, there you go. Your goal is to go from there to there. Okay, so you are not working on that side. So don't think about that side when you're doing your steps, except to know when you're done. And as with most proofs, there's multiple ways to do these problems. Okay. I'm literally giving you a chance just to try things out first before we start actually going through doing it.
Can you factor out exponents?
Yeah, you can factor things out like that. All right, so what do we want to try? Yeah. Okay, so we've got cosecant squared x, and then I have cosecant squared x minus 1. Okay. I don't know if this is the right way to go. Oh, okay. I'm like, you'll notice on these problems, a lot of times you'll start a problem, you start a way to go, and it's like you'll get into a loop that it's like, oh, can't go that way. That happens. Don't freak out. Don't get mad. It happens. And it happens to all of us, including me. Like, I guarantee you there's going to be problems on this board where we're going through doing them that I'm going to go through doing it. And I'm like, oh, yeah, I can't do that. Have to go back and try a different way. It's going to happen. All right. What's next? Yeah. Okay. So Pythagorean identity, the cosecant squared is 1 plus cotangent squared. So we're changing. Oh, wait. Okay. All right. So we're using, hold on, I'll copy the rule over that we're using because we're using it 2 different ways. All right. So that's the rule. But we are also doing that one. Okay. All right. So we're going to change. Well, actually, you know what? I'm going to do colors so we can see. We're going to change this one to 1 plus cotangent squared x. And then we're going to change this to cotangent squared x. The question is, and I don't want you to answer, is why would we do that? What piece of, because we're not using the answer part, but we're using the answer part to guide us. Okay. So what is what are the two things that really change from the left side to the right side? The positive and negative switch. And what else? Well, the exponents don't really change, they just change places. And remember, addition, I could swap them and it wouldn't make much difference. What else changes? Yeah, cosecant changes to cotangent, right? So somehow we need to change the minus to a plus and the cosecants to cotangents. The only way that we really have to change cosecants to cotangents is the Pythagorean identity. Okay, so we know we're going to have to use this identity. The other nice thing about it is it has a plus in it. So maybe we can somehow change that minus to a plus, which is what we did by factoring out that cosecant. We got a 1 in there, which we needed to use the Pythagorean rules. Okay, because remember that question before, is it always a 1? Well, not necessarily. We might have to factor something out. In this case, we had to factor something out to really use it. All right. So now, the final step is to distribute this back out, basically. So we have cotangent squared x plus cotangent to the 4th x, which is what we wanted at the beginning. So we did Pythagorean here. Oh, actually, hold on. We did algebra here. We did Pythagorean to get this step, and then we did algebra again. My suggestion when you're doing these is do not try to type them directly into Alex as you're doing them. Do it out on paper and then type your work into Alex. Okay? So we now have Alex. So the first thing I did was factor out a cosine or cosecant of x.
Oh.
Notice I'm not using these. If you're using a keyboard to type it, you can type it. It'll automatically fix things for you. If you use the Shift 6, the caret key, it'll make your exponents for you. So you don't have to click the buttons to get them to do it. If you're doing it on a tablet and stuff, it's actually, the touch is easier to actually type things in there. But all right, and we did algebra there. Here is the nice thing about Alex. You have to click validate. It will not let you go on to the next step unless it is correct. Now, it will let you go on to the next step as long as the step is correct mathematically. Not necessarily that it will help you get to the answer. Okay? The other nice thing is the very last step, you always have to click validate. You will never get these wrong. Okay? You cannot physically get these wrong in Alex because it will not let you validate unless the steps are all correct to get to the final answer. And your final answer has to be what they gave you. Okay? Now, you could get things wrong in here where it won't validate and you might have to fix them, but it won't mark it wrong until you click the check button, and you can't click the check button until everything's right. Okay, so you cannot get these wrong in Alex. All right, next step we did was we actually did the Pythagorean identity twice, right? But that's fine because I can do it in one step in this problem. I don't have to type it in twice. So it was cotangent for x plus 1. And then this one was just cotangent for x. There's a bunch. That's Pythagorean. Let me check. You could have done that as 2 steps, And doesn't Pythagorean twice, that's fine. You can do that. And then the last step was so actually I'm going to show you. I'm going to screw this up on purpose. And we did algebra, validate. This line's incorrect. I just typed cosine instead of cotangent, but
But the same when you're doing, like,
this is the topic. Yes. Oh yeah, yeah. It's the exact same if you're doing the topics. I'm sorry. Yes, I'm doing it not in the topic, but yes, it's the same. Validate says your proof is complete. That's when you can hit check. It will not let you hit check until it says your proof is complete. Okay, so you can't get these wrong. So you will not have to do a billion of these. You might sit there spend an hour on one problem because you can't figure out where to go, but you're not going to have to redo them. You're only going to have to do 3 per topic, basically. All right, let's try this one. It sounds like a way, right? Literally, because you can just do this. My high school class, they used to literally walk around the room, just right out, teach class from everywhere. So when the kid was driving me nuts, I took extra.
That's me.
So, you have those, you want that. How are they going to have to use that? The goal is to figure out how to get.
Yeah, that's looking at it. It's just so
Sorry, you're good. This is one of those rules that's actually very helpful in a lot of situations. Remember the difference of squares from algebra class? You had x squared minus y squared equals x minus y, x plus y. That rule. So it's also quite used quite often when you're doing conjugate pairs, which you might have seen before, especially when you're looking at complex numbers and stuff like that. So conjugate pairs allows us to square things and get rid of the middle terms, which drives us, that's when we're looking at polynomials. When you're looking at ones with fractions, sometimes the conjugate pairs helps you break things down a lot easier because you can multiply the top and the bottom by the same thing. It could possibly change your top into just one in a lot of situations if it's sine and cosines like this. And then you can deal with the bottom, which might end up making your life a lot easier. Things can cancel out that way. So we have this right here. Those are conjugate pairs or the difference of squares. So this becomes 1 minus cosine squared x. Because you have 1 plus cosine x minus cosine x minus cosine squared x. So those two terms in the middle cancel each other out. And then, so that's my algebra step. And then I have my Pythagorean identity, which is this. But if I move the cosine squared x over, I have sine squared x equals 1 minus cosine squared x. So that goes to just sine squared x. That's why I said these problems, it's going to take practice. It's going to take doing a bunch of them to really start looking at what's going on. That's why those first 3 topics that you're going to have to do where they list out all the steps is so important. It's because those are the ones that are going to give you those things like, okay, let me try this, or these are some of the things that I've seen before. It's going to take you a little time to get it done. That's why I said this is the hardest chapter. Because there's no roadmap. It's not every problem is going to be different. It's like you're not going to say, oh, I can always do this, this, and this and get the answer. It doesn't work that way in this topics. So
Choose your own effect.
pretty much. All right. So actually in this one, there's really only 2 steps.
What's the other one? What if you put it 1 minus 1 over time? Change those. And that's what I do now.
Yeah, you were thinking it's cosecant, not cosine. At least I'm going to hope, because otherwise I have no idea what you're doing. So type those in, hit validate, proof is complete, hit check. So looking at this problem, what do we have to do? We somehow have to get rid of everything, right? So somehow I got to make things the same. Okay. So what would you like to try? Yeah. Okay. So this becomes cotangent squared x plus 1 minus cotangent squared x equals 1. And then the cotangent squared x's cancel out, which is just 1. Works? 2 steps, right? Okay. Oh, hold on. I'll go back so people can finish writing it down. We good? Yeah. No. So yes, you could, but basically what you have to do when you're doing it, since you're doing 2 different rules, because you're doing the Pythagorean identity and then you have to do algebra to clean it up. That's why it has to be the 2 steps. So because just the Pythagorean identity alone won't get you to 1. Actually, oh yeah, you actually might be able to do that in 1 step. Because that's true. The rule's that. So if you move that over, yeah, you actually could do that in 1 step. So yeah, you could actually go just put 1 instead of Pythagorean rule identity in this situation. I didn't do that. I should have done that one. That would have actually been a nice little test. I wanted to show you how it will let you go a roundabout way to do a problem. Okay. What was one of the things that I said you could do if you're kind of stuck? You're kind of stuck. What's the one thing to try to do first? Change everything to sines and cosines. Okay. Because sines and cosines, a lot of things work with them. Okay. So I did that. I changed cosecant to 1 over sine, cotangent to cosine sine. Oh, I didn't switch it over. Darn it. There we go. Again, I changed this to this, and then I changed it to quotient rule. And then since they're both over sine squared x, I could put them together. And then, oh, I have the Pythagorean identity up there. Oh, now I have sine squared x over sine squared x, which equals 1. It will let you do it. Every one of those steps is mathematically correct. Okay, and that's fine. That's what I'm saying. Like, it will let you do that. Every one of those steps is mathematically correct, so it will prove and it'll verify it. Okay. As long as you get to the final answer and it says your proof is complete, it is right. It might not be the fastest way to get there, but it's right. And as we just saw, we had 2 we thought were the fastest, and he got into 1. So it can happen that way. I want to actually see how they did it. They literally did it. Nope, they did it in 2 steps. They did it in 2 steps. But yeah, you should have been able to do it in 1. So, okay.
This is that type of math you can't
Nope. You type any of this into a computer, it's literally going to tell you true. It'll literally tell you true. That's it. And if you tell it to simplify it, it might give you the answer that they're giving it to you. It might give you something else because you can simplify them a lot of different ways. It doesn't necessarily have to be equal. That's that. And so there's 7 of these. I'm only on problem type 2. Like this is something that if I take more time on it, I take more time on it to make sure you actually get it. Are good. So I can always push it if I do some stuff, chapter 5 on this, some stuff, chapter 5. Oh, yeah, so I would see that's going up to my actually just become so you don't have to do the extra stuff. It's not wrong. It didn't save you that extra stuff. This is 5 weeks. So, look here. You move that one over. You now have sequence minus 1. Yeah, the Pythagorean, you can, any manipulation of the Pythagorean theorem, you do still the Pythagorean again. You did a little bit. That's the legal. Kind of the long way. It happens sometimes. Just finding out a new way to think about it. Yes. All right. So we want to get rid of that one. I don't have any ones in my answer.
The way I was doing it, that was actually got
Probably.
just theory by theory.
Whenever you see something like that, and I don't have a one in my answer, think Pythagorean. So let's deal with that part first. So I have the rule secant squared x equals tangent squared x plus 1. If I bring the 1 over, that becomes just tangent squared x. Because it's secant squared x minus 1.
Does it matter if it's a minus or one in those identities?
Yeah. It's the way this is set up. See how secant squared x equals tangent squared x plus 1? If I subtract 1 from both sides, now I have the secant squared x minus 1 equals tangent squared x, which is what I used to
Oh, so
replace
it's
it.
all the same thing.
Yeah, it's just manipulating the Pythagorean identity. So now I have that. Tangent becomes sine squared x over cosine squared x. And then that's just sine squared x. So we have Pythagorean, quotient, and algebra. All right, try this one. I highly doubt anybody did it that way. That's literally why I wrote that one. Because you like flipping things over all the time. Which you should have done, which the fastest way to do this would actually have been to realize that that right there is cotangent. So if the, remember the whole identity is cotangent squared x plus 1 equals cosecant squared x. So that would be that one. So you would end up getting tangent squared x and then cotangent squared x for that step. Then you could have done the reciprocal from
So you need
for
to
that
add
one.
the +1 to that. Cotangent squared x +1.
No, because I switched over this. I'm replacing cosecant squared x minus 1.
Ah, it's so confusing.
Which that does equal. Yes.
Can you also turn tangent squared x into sine of a cosine?
That's actually how they did it. Yeah, they changed the tangent squared x into sine over cosine, the cotangent squared x into cosine over sine, and canceled them out. So yeah, they actually did it that way. This is just it. That's the thing you're seeing, like that there is a lot of different ways. All these answers are right. Okay. There's a lot of different ways you're going to get to the final answer. As long as each one of your steps is mathematically correct, you're fine. All right. So yes, when I have to go through and grade these tests, I literally have to look at each one of your steps in every problem. It's not like there's no formula for it because everyone can do it differently and that'd be fine. So this test will be even harder than my other test to correct, but that's okay. The more practice, the better you'll get at, and the faster you're going to get through it. You basically is what's going to end up happening on some of them, and I can guarantee it, is that when you're going through and doing your steps, you're going to screw up something without realizing you screwed it up. Or you're going to get to a point where you're going to like, I have no clue how to go further than this to get what you asked for as the answer. And you'll get partial credit for that. Or like I said, you'll make a mistake somewhere in the steps and you might undo the mistake. So you'll still get the final answer right at the end, but that's where you'll end up getting the partial credits. Because unlike Alex, you don't get to validate your steps as you're writing them down. So no. Because again, like this stuff, when you go further in it, that's the things that you really truly need to understand. Like you're not going to have the answer that is there. It's like it's not even going to tell you the answer that you're trying to get to. You realize like, okay, I need to get this to its multiplication, no addition and subtraction, because the product rule is going to be easier than this one. Or I need to break it out so it's a whole bunch of addition parts because I can use those will be easier to break down my integral, those type of things. So. All right. Let's do this one. And I even did a crazy that one for you to see if I could match up with yours. Okay. Well, that's just me going quicker than you are.
I immediately go to the typical rule. I don't know why.
You're fine. You're totally fine. Actually, with reading that book the other day, I was going through and actually writing off the few times, and Kate used that format. I'm like, I haven't seen that one in a long time. It's like, so you're fine. It's just one of those things like when I'm reading it, I have to make sure I catch it because it looks like CO, it looks like cosine. No, it's.
Was this an easy one?
I don't know. Finally. He's like, I got it. That's it's like, and I'll ask you some of these, like this one actually is problem type 3, actually. It just happens to be.
All the other ones that probably would have gotten.
Yeah, you just need a little. Yeah. It's starting to click. It's like, okay, let's try this instead of something crazy. All right, so let's change this to. That changes to what? Cosecant. And now let's go to sines and cosines. Oh, actually. So in Alex, you have to actually write this as 2 separate steps. I typically would not have when I wrote it down on my paper. And I wouldn't, if you wrote it as 1 step and you wrote, I use the reciprocal and quotient rule, I'd be fine with that on your test. But yeah, because I want to know what you're actually using. Well, no, you can try things out, like, but just tell me what you're trying. Like I'm using Pythagorean here, or I'm using quotient. I use the quotient and reciprocal rule here. That's fine. Just tell me what you're doing in the step. It's not like identifying the rules. It's telling me like, what are you trying, or what are you doing here? That's just as important as the thing for this class because I'm trying to get you guys to understand how to use the rules to manipulate things.
And,
So.
and how are they going to kind of like mark you wrong if you don't do like the parentheses?
No.
First, you do either one first.
Yeah, if you went from you did this step first. Yeah, that's fine.
Okay.
Yeah. Because it's still, again, it's looking for mathematical correct. So if you put sine x over cosine x parentheses 1 plus cotangent squared x as your first step, that's fine because you use the quotient rule, no problem. So yeah, order doesn't matter as long as like you just didn't do multiple steps at the same time. Yeah. I would never have left it like this. I would have wrote this as secant x, cosecant x. It's literally just the reciprocal of it. Because remember, 1 over cosine is secant, 1 over sine is cosecant. It's just literally flipping them back over. I would never have left it as 1 over something that's.
This is a lot of.
So yeah, it's like it's more things to write and more things that you could possibly like mix up. And it's like it's easier just to if I need it underneath, switch it back if I really needed it that way. All right, let's try one more, and then I'll let your brains unfry.
Do you know, for chapter 7's homework? Is this it for chapter 7? Okay, so we can just go through now.
You can start working on it. There's other more advanced rules that we haven't got into yet, but yes.
Oh, okay, so once we get to those, we kind of stop.
Yeah, it's like there's more. I'll show you in a minute because I have one.
There were like word problems in there. I got scared. Did you look?
No.
Oh.
So there's not.
It was like changing lengths of a triangle.
Oh yeah, those are actually, believe it or not, those are actually. Once you look at those are really you'll figure those out quickly. Those aren't actually hard word problems now. Actually, we'll do this one and I'll show you the other 2 quick topics that probably pop up first. I'll show you the Confucius one that you asked for. Yeah, because those pop up first, and I'll show you. I'll do those 2 before I let you go. We'll try this one because honestly, those I didn't put in there. Let's get those topics up real quick. Yeah, some of the stuff at the end is solving and modeling real world problems. We'll do those towards the end. But 90% of it's proofs and stuff. This topic. And the other one was all right. So what do you want to try first? Very good. Yep. Let's do Pythagorean. So we'll change that one to cosine squared x. So that's Pythagorean. And then what next do we want to do? Yeah, let's get these to sines and cosines. So cosine squared x, and this is 1 over sine x. So that's reciprocal. I want 1 cosine x. So if we swap, we split that up. That's an algebra step. And then I have cosine x, cotangent x, and that's a quotient step.
What?
Remember, cosine squared is just cosine times cosine, right?
Yeah.
So I have cosine times cosine. So the first, because I want a cosine, and then I need a cotangent, which is this cosine over sine. Hang out for 1 minute. I got 2 other problems I'm going to show you real quick that aren't proofs, but they've come up before a lot of the other stuff. And it's something you should be able to figure out on your own, but I got a couple questions, so I might as well show them to you real quick. And they're not good. Compared to this, it's quick. So, yeah, so we're just flipping those over. All right, so the first topic that seems to come up is the confused co-function identities. These are ones that honestly, I already talked about this. Remember the concept of that sine and cosine are shifted by 90 degrees or pi over 2? So the co-function identities are ones that are literally shifted by pi over 2 or 90 degrees. So if it gives it to you in degrees, you're just going to make 90s instead of pi over 2s. All this is matching them up. So this one's cotangent. So I'm going to change it to tangent by subtracting pi over 2. So it's tangent of pi over 2 minus pi over 11. So it's tangent of, let's see, 11 minus 2 is 9 over 22. Pi. It's just fractions. Just use a calculator to do your fractions. 1/2 minus 1/11. And that's it. That's literally all this topic is. So as long as you can remember which ones match up, it's just adding it's just literally minusing it from 90 or minusing it from 2 pi. Okay. The other topic that comes up is they'll tell you, they give you an angle and they give you information about it. And they want you to find some of the other trig functions. This is right angle trig. So all they're giving you, they're going to give you 2 pieces of the triangle. You just have to remember that sine is y over r, cosine is x over r, tangent is y over x. Radius.
That's 205.
So they gave me cotangent, which is the flip to this one, right? They gave me cotangent's 2 over 5. So that's x and that's y. So 2, 5. X and y. How do you find r? Pythagorean theorem. So 2 squared plus 5 squared equals r squared. So I got 29 equals r squared. So it's the square root of 29. Okay. First quadrant, x and y are positive. Second quadrant, x is negative, y is positive. So in this case, since it's in the first quadrant, x and y are positive, so everything's positive. So sine is 5 over the square root of 29. And secant's the opposite of this one. So secant is r over x, so it's the square root of 29 over 2. And those are your 2 answers. So find whatever piece you're missing on the triangle and then plug them into the formulas. That's all you're doing on this topic. That's why I didn't really do those because those are like ones you should be able to figure out if you do them, but I'll do them. All right. Try to start practicing some of the proof stuff. We'll go through more of it on Thursday. We'll go through more of it next week. It'll be a scary Halloween. So.
Yeah.
Oh, geez. That's fun.
Alrighty, thank you.
You're welcome. I'll see you on Thursday.
Hi.
Bye.
Date of our next test.
I think it's right before Thanksgiving, but it might move.
Okay.
It really, honestly, it depends on how you guys are getting this, because this is the stuff that I might expand a little bit
Yeah,
and take a little longer. So it might be right before Thanksgiving. It might be right after Thanksgiving. I'm
Okay.
not sure yet.
yeah, no problem. Thank you.
I haven't finished correcting them yet. On Thursday. You too.